Okay, so now we're going to solve linear inequalities. And solving linear inequalities, other than making sure if you divide or multiply by a negative, flip the sign, really the solve part's the exact same as solving linear equations. The only difference is you're going to have a set of solutions, meaning your solution set's going to involve a range of numbers, all right? Again, infinitely many numbers can answer this set. All right, so this is an example, and then I'll get into ones where I'll actually solve them out for you. All right, so this is just an example to show you kind of how it all pans out when you solve these. So the first one is, I want to know all of the x values, where 2x minus 3, when I plug them in, 2x minus 3 will be less than x plus 2 over negative 3. All right, so I solve this the way I would solve it with the equation type. All right, the first thing, though, we're going to do is I want to get rid of the divide by negative 3. So the first thing you're going to do is multiply by negative 3. Since I'm multiplying by a negative, we flipped the sign, and you'll see that the sign is flipped. Okay, so we flipped it there. And that's the big thing to remember because we multiplied by a negative. Right? Then the next step is, well, I've got rid of the division by 3 by multiplying out. So the next thing we do is I move the x term over. So the next thing I'm going to do is I add 6x to both sides. Right? That's how we move the 6x over. And so we got the 7x here when I added it to the other side. Next step is to get rid of this 2, so we subtract by 2. Alright, so that gives the 2 the other side. Subtract both sides, so I get rid of the 2 when I subtract 2 here. I take 9 and I subtract 2, that's where the 7 comes from, and so now I've got 7 greater than 7x. The last thing is you divide by 7. Since 7 is a whole number, we leave the sign the same, right? We don't flip it here, so it stays. And so we get x is less than 1, or again, the way it's written, 1 is greater than x. But what we can always do with these is you can write it the other way around. And it's more proper to actually write it the other way around. Just make sure, kind of the elementary way to think about it is always make sure the symbols, mouth side is always to the mouth side it's supposed to be. So 1 is greater than x is the same as x is less than 1. Right? And so again, it's the open mouth is approaching 1 on both of these. So this is, again, the way we prefer to write it, so you can always do this. And so the set builder notation is I want all of the x values such that x is less than 1. All right, the interval notation means, well, x has got to be smaller than 1, so I'm shooting off to negative infinity. It's a parenthesis at 1 because 1 is not included. All right, and so now we're just going to sort of practice. I'm going to do a few more examples of this type of problem. Alright, so the first example is actually going to be very similar to this. Alright, so 2 minus t less than 6, or divided by 6, less than or equal to 5. Alright, first step, get rid of the divide by 6, so I'm going to multiply both sides by 6. And so, again, those reduce, leaving with 2 minus t less than or equal to 30, right? 5 times 6 is 30. Next step, get rid of the 2 by subtracting the 2. And so here, don't forget this negative. It's really easy to forget it. It's still there. So I have negative t. So that's the only thing that's gone. Less than or equal to 18. Oh, sorry, not 18. 28. 30 minus 2 is 28. And then get rid of the negative. And remember, when I get rid of the negative, I've got to flip the sign. So t is then flipping this greater than or equal to negative 28. You can always check your answer if you're worried you didn't do it right. If I go back and sort of erase what I had here in the original, pick something that's greater than negative 28. 0 is greater than negative 28, right? So if I test this out and I plug in t0, because 0 is bigger than negative 28, and if I plug 0 into this, well, this will 0 out, and so I'll get 2 over 6 is less than 5. Well, 2 over 6 is 1/3. Well, 1/3 is less than 5, and so that's true, so it checks. Alright, so you can always check this. Not sure why I decided to cross it out. Alright, but it checks. Alright, so there's and again, that's not the answer. The answer is written in set notation first. So set notation is I want every t such that t is bigger than or equal to negative 28. interval notation. Well, it's bigger than, so I know I'm shooting off to infinity. Negative 28 is where we start. I include negative 28 because it's equal to, and so the interval notation is I can plug anything between negative 28, including negative 28, up to infinity, and it'll make the equation true. Next example. Negative 3 times z minus 4 is greater than 2 times 1 minus 2z. Alright, so there's a couple ways you can do this. I think it's just easier if you go ahead and distribute the answers. So we're going to go ahead and distribute the negative 3, distribute the positive 2. So again, multiply through by my negative 3 to get negative 3z. Negative 3 times negative 4 gives me my positive 12, still greater than because I didn't do any subtracting or dividing. 2 minus 4z. All right, then it's up to you how you want to go. Again, I try to avoid negative so we don't have to worry about moving the sign around. So I'm going to kind of look here. If I add 4z, I'm going to get rid of the negative z. So I'm going to add 4z to both sides. That gets rid of that. I've got a 4z minus a 3z, which will give me 1z plus 12, still bigger than 2. Now move the 12 over. Minus 12, minus 12. And so I'm left with z on this side, greater than negative 10. And again, I didn't do any dividing or multiplying by a negative, so the sign never flipped. And so there's the answer, except writing it into the two notations. All right, so first the set notation. I want every z such that z has got to be bigger than negative 10, or the interval notation. Bigger than negative 10 means I start at negative 10 and I'm shooting off to infinity. There's no equal to, so it's parentheses. Negative 10 to infinity. I pick any number between negative 10 to infinity, it'll make it true. And you can always test an answer. Again, 0 is a number between negative infinity and between positive infinity and negative 10. And so if I go back up to the original answer and sort of check and make sure I've done it right, you can always check your answer. So I'm going to check. I'm going to pick z equals 0. That lands in my group, right? Lands in my set. And so if I plug in 0, 0 is just an easy number, right? Because I plug in 0 here, that 0's out. It's going to leave me with negative 3 times negative 4, greater than 2 times 1 minus, again, that 0's away. So that's really 1 when I'm left over. And so over here, I'm going to get negative 3 times 4, which is positive 12. Greater than positive 2, and that's true, so it checks. So again, you can always check it. Make sure you're careful, alright? So that's a couple of examples. So again, solving inequalities isn't any different than solving equations other than keeping track of if I have to flip my sign. And the only time you flip your sign is if you divide or multiply by a negative. That's it. And then write your answer, and your answer is always going to involve a group of numbers, right? There are infinitely many numbers between negative 10 and infinity. All of those numbers make the original equation or inequality true. Alright, so again, make sure you practice those. We'll stop there. We're actually going to learn more methods. I'm going to talk about how to solve them with the graphing method, zero method, and so we're going to get to other methods. So that's the algebraic method. And now we're just basically going to go through the different methods and how to solve it graphically. So that's the next video.